Hello and welcome to another edition of Booze and Hacking. I am your host, Dark Hoodie. We are back with another TryHackMe room. This one is called Heartbleed, and if I'm not mistaken, it's probably addressing the Heartbleed vulnerability. So let's take a look at this room. I already have my IP address here, and it is giving us a brief introduction to what the Heartbleed vulnerability is. So most web servers are configured to use SSL/TLS. SSL is the predecessor of TLS. Most common versions are 1.2 and 1.3. Configuring a web server to use TLS means that all communication from that server to a client will be encrypted. Any malicious third party that has access to this traffic will not be able to understand or decrypt the traffic, and they won't be able to modify it either. And we can learn more by checking 1.2 and 1.3 out. Heartbleed is a bug due to the implementation in the OpenSSL library from version 1.0.1 to 1.0.1f, it looks like, which is very widely used. It allows a user to access memory on the server which they normally wouldn't have access to. This in turn allows the malicious user to access different kinds of information that they wouldn't normally have access to due to the encryption and integrity provided by TLS, including the server private key, confidential data like usernames, passwords, and other stuff. The implementation error occurs in the heartbeat message that OpenSSL uses to keep a connection alive even when no data is sent. A mechanism like this is important because if a connection dies or resets quite often, it would be expensive to set up the TLS aspect of the connection again. This affects the latency across the internet, and it would make using services slow for users. A heartbeat message sent by one end of the connection contains random data and the datum's length. This exact data is sent back when received by the other end of the connection. When the server retrieves this message from the client, here's what it does. The server constructs a pointer to the heartbeat record. It copies the length of the data sent by a user into a variable known as the payload. The length of this data is unchecked. The server then allocates memory in the form of 1 plus 2 plus payload plus padding. This can be a maximum of all the way up to 655.35 plus 16. The server then creates another pointer to access the memory, copies the payload number of bytes, sends the data contained in the BP pointers to the user. With that, you can see that the user controls the amount of data, and if the user does not send data over, it means the server will copy arbitrary memory into the new pointer, which is how it can access secret information on the server. When retrieving data this way, the data can be different with different responses as the memory on the server will change. The way this is remediated, the server needs to check the length of the heartbeat message. So, here are some references in case you want to read up more about this. We're done with this portion here. And now, I have to find a flag. It says here you need to obtain a flag using a very well-known vulnerability. Make sure you pay attention to all the info and errors displayed. Pay particular attention to how web servers are configured. Okay. So I have already started the machine, obviously, and I've run the nmap scan with my trusty Python script. And I see here port 22 is open. which runs OpenSSH. And here is a list of CVE numbers that Vulners has found. Port 111, which is RPC bind, is also open. Here are the program versions. Port 443 obviously is open, and they're running the Nginx web server over port 443. And I'm looking here, it says the Apache web server is vulnerable to a denial of service attack when numerous overlapping byte ranges are requested. That's important to know. And here we have the main topic of today, the SSL Heartbleed vulnerability, which is letting us know it's a serious vulnerability in the popular OpenSSL cryptographic software library. It allows for stealing information intended to be protected by SSL/TLS encryption. The risk factor is high, so right away we know to check the versions of OpenSSL to make sure that they're not affected by the Heartbleed bug. What else is open? 43009 is open. That's also RPC. All right. So where should we begin? I'm thinking possibly Metasploit to see if there is a vulnerability for this. So I'm going to go to my next shell here. I tried Nikto before, but it didn't give me anything, strangely enough. So I'm going to clear that. And I'm going to go to Metasploit. Let's wait for that to open. All right. And Metasploit is opening. Wait for it to finish. All right. So I am going to search for Heartbleed. Let's see what we get. And we get a few here. And let's see, the first one says it is, see if there's anything here that references, how about number 4? That looks good. The auxiliary scanner SSL, OpenSSL Heartbleed. That looks like a good one. We're going to go with that. So let's use 4 and show options. So what this does is it scans hosts for the vulnerability. And let's see what I have to set up for myself. So obviously our hosts is needed, our port, and what else should I choose? We have leak count, our host status, how many retries. Well, let's go ahead and set up. So let's set our hosts to, what is our IP address? 3. Let's copy this. I've never seen a TryHackMe one that didn't begin with 1010. That's interesting. Okay. And our port is, set our port, it is 443 already. And let's see. curious about this retry status every. I'm going to set verbose to true. Let's give this a run. Cross our fingers here. Oh, a lot of stuff here. Okay, the scan is finished. Start at the top. There's a lot of stuff here. And look at this right at the beginning. Username is hacker101. User email is hacker@hacker.com. User message. And that looks like a TryHackMe flag. I am going to copy this and see if that is what we are looking for. A lot of data here. This is a scan that really looks for everything. Scan is complete. Let's go back here, see if this works. All right. And we are done. That's it. So basically, that was our lesson in Heartbleed. Pretty easy to find. I have to remember this script here from Metasploit. Gave us a lot of data here, lots of data here to pour through, sites to look at. It was easy to pick out the TryHackMe flag. So all in all, a good lesson. So thanks all for hanging out with me today. I hope you learned something. I know I did. If you enjoyed this room, please like and subscribe to my channel. And I hope to see you all in the next video. Everyone stay safe and hack the planet.